Hey guys, welcome back to Jyoti classes. And today we will be continuing with the next part of quantum mechanics, where in the last class we have gone through few of the formulas, and now today we will be starting with few more formulas. So let us start with the first formula, that is for one dimensional potential well for the given wave, what is the wave function and the energy for the potential well. If the potential well is asymmetric potential well, then the potential is given by V is equal to, so the potential is represented by V is equal to 0 for x greater than 0 and less than a, and it's infinity for the other conditions. The wave function is represented by xi n is equal to root of 2a sin n pi x divided by a, where a is the length as we all know. Then the energy value is En is equal to n square pi square h cut square divided by 2 ma square, where n can take the values from 1, 2, 3 so on up to. This is the condition for asymmetric wave function. If this wave function, if the potential well is symmetric, then the potential is V is equal to 0 for x greater than minus a less than a, and infinity for the other conditions, followed by, if the energy is represented by E is equal to n square pi square h cut square divided by 2 ma square, where n is equal to 1, 2, 3, 4. But here the wave function for the limit a minus a by 2 to a by 2, it is xi of n is equal to root of 2 by a cos of n pi x divided by a, where n is equal to 1, 3, 5 so on up to. For the odd values, the wave function will be the cos of n pi x, and for the even wave function, for the even n values, that is n is equal to 2, 4, 6 so on up to, xi n is equal to root of 2 by a sine of n pi x by a. We have to remember this while solving the problem, whether it is a symmetric wave function or it's a symmetric potential well or a asymmetric potential well. Based on that, we have to take the wave function formula. Okay. Now let us move on for the 2D potential well. For 2D box or 2D potential well, potential is with between the two values of x and y ranging from 0 to a, and for other conditions it's infinity. And the wave function is represented as xi of nx ny is equal to 2 by a sine of nx pi y by a sine of ny pi y by a. This is the for 2D wave function, and the respective energy is nx square plus ny square pi square h cut square divided by 2 ma square, where nx and ny will take the values from 1, 2, 3 so on up to. Okay. See, here the values of x and y are ranging from 0 to a. That's why we have the energy has nx square plus ny square, taking length as equal for both the condition. If the length is different for the different boxes, if x is ranging from a to b length, then the wave function will become root of 2 by a sine of nx pi x divided by a, and root of 2 by b sine of ny pi y by b. So you have to remember that whether it is the condition for the length of a given potential is same or different. Based on that, you have to take the respective wave function as well as energy. Okay. Next, it is for the 2D wave function, 2D box, and now for the 3D potential well, the wave function x, the potential x, y and z lying between 0 to a, and the respective wave function is root of 2 by a sine nx pi x by a, root of 2 by b sine ny pi y by b, a, root of 2 by a sine nz pi z by a. Okay, where nx, ny and nz will take the values from 1, 2, 3 so on up to. And the energy formula for the given wave function is nx square plus ny square plus nz square pi square h square divided by 2 ma square. This is the value for the 3D box. Okay, next, what like how will we calculate the expectation value? The formula for the expectation value is nothing but the mean of the given function value or average. Okay, then it is represented by this form, and if the expectation value of a is bracket of a cap divided by normalization of the given function, you have to write, we know that this is equal to 1 always whether it is a normalized condition. Okay, now if the wave function is given in the form of a xi1 plus b xi2, then the expectation of the energy is summation of n en pn, that is equal to e1 p1 plus e2 p2. We have to take energy for the first level and the energy for the second level, followed by the probability of finding the particle at that state, p1 state and p2 state. Okay, the next formula is the formula for uncertainty. Delta of a cap is equal to root of expectation of a square minus expectation of a the whole square. You have to remember this formula because this is the important. Most of the questions are asked on the uncertainty. Okay, thank you guys this much for this video, and will be followed by few more questions in the next video.